Introducing Pixie II. It's smaller, faster, and smarter than the original Pixie. Pixie II can do everything Pixie I can do. You can teach it several objects, and it will detect them, lots of them, including color codes. And just like the original Pixie, Pixie II feels right at home riding on a robot, like this little tank-like robot. And yeah, you can do that too. Pixie II has a custom pan-tilt mechanism, so it can look around while it does things. It is faster than before, processing images at 60 frames per second. It's faster, so your robot can be faster too. It is not recommended that you use Pixie with heavy machinery. Pixie II has also learned some new skills. It has new algorithms that can locate and track lines, and a built-in light helps it see better when the lighting needs a boost. New algorithms can identify intersections in your robot's path and report them. Your program can decide which path to take. Pixie II can also identify little signs and report them to your program. The signs can tell your robot what it should do. The signs are simple barcodes. You can print them out and choose what each sign means, depending on what you want your robot to do. Up to 16 different signs can be identified.
Build their projects. It comes with multiple functions, such as face recognition, object tracking, object recognition, line tracking, color recognition, and tag recognition. By a simple click, HuskyLens will start learning things, just like this. To play with it, the application of HuskyLens is truly versatile, from smart robots to interactive art projects. The object tracking mode of HuskyLens is innovative. The machine learning technology enables HuskyLens to learn custom-defined pattern of finger gesture and recognize it. Creating a gesture interactive art projects has never been so easy with HuskyLens. Put HuskyLens into a robotic dog and switch on the face recognition. New face can be learned and recognized. A unique pet is now alive. The color recognition makes the scenario even more fun. Learns a new ball and follow it. The interaction to the robotic toy has been brought to a new level. HuskyLens is more than just a color picker. Up to 10 different objects can be detected and recognized. With few clicks, the object is learned and selected. Click to switch on the line tracking mode. HuskyLens is now learning new lines and follow them. Tag recognition provides new possibility for applications, making an autonomous robot has never been so easy now. HuskyLens is engineered with a built-in UART interface which makes it compatible with most controllers such as Arduino, Raspberry Pi, Latte Panda, and Microbit. HuskyLens is extremely easy to be integrated into any projects and brings the intelligence of projects to a new level.
This is the new OpenMV-Cam H7. It's a hackable, expandable computer vision module that fits in the palm of your hand. Our goal with the OpenMV-Cam project was to create a super simple but flexible computer vision platform that can instantly power on in seconds for applications in the real world.
What I like about OpenMV is, first of all, it's a single contained package that has the camera, the processor, and the MicroPython environment. What I really like is the IDE, the development environment, which is Python, which is easy to use. It's interactive, so you get to see the results in real time. And it's otherwise, you just plug and play. And that's huge advantage in just getting right down to the computer vision.
Folks have been begging us to release the OpenMV-Cam H7, and it's finally here. The OpenMV-Cam H7 is a much improved version of the OpenMV-Cam M7. We have all the same features like color tracking and April tags and face detection, but now with double the processing performance. We now have a removable camera module system, which lets you easily replace the current camera module for things like global shutter imaging, to capture fast action and eliminate motion blur. By combining the OpenMV-Cam H7 with a FLIR Lepton, you can now create a thermal imaging camera that can run off battery power.
So it's like having a superpower of, two different kinds of vision. You can see the world the way a human sees it, or see the world the way an insect sees it, and by combining the two, you can see the world better than both.
The additional processing power finally allows you to run neural networks on images in the wild.
The exciting new feature that's coming out with this is to be able to do deep learning. Convolutional neural networks, being able to kind of run inference layers.
Since we introduced our original OpenMV camera, we've shipped over 10,000 units and seen amazing applications utilizing our hardware. We've seen students build autonomous cars capable of following a line. We've seen drones capable of automatically landing using computer vision, and everything else in between. Since our original campaign, we've now got 5 shields for you to add to your OpenMV camera. We've got a proto shield, a servo controller shield, a motor shield, a Wi-Fi shield, and finally an LCD shield. Let's say you want to build an autonomous remote controller car. With the OpenMV camera, you can literally put all the brains right in one module at the top and run some servo controller wires down to an RC controller down here and an ESC for motor control.
Like any great video game, it's easy to pick up but hard to master. I think OpenMV is easy to pick up, but then there's this extraordinary amount of depth still there waiting for you to master.